Hello, I'm Park Wan from the first semester of the master's course in artificial intelligence at Korea University. The research I'm working on is the improvement of the one-stage anomaly detection discriminator-based data, 그 augmentation model. It's about the research background. I will talk about data imbalance. Most real-world data is unbalanced from class to class. If the unbalanced data is unbalanced generation, performance is degraded due to the lack of learning about minority class in the classification model. For structured data sampling is used to address the data imbalance. The following is about related research. I will talk about the improvement of GAN's learning through the attention map. SA can drive the attention map by separately organizing the attention module. GAN learning through the attention map complement each other's disadvantageous convolutions at the long-term dependency because it is possible to consider the long-term dependency. It showed that the generator can be adjusted using the attention map, which can improve the performance of the GAN model. However, there is a limitation that the structure is complicated by the addition of the attention module compared to the existing GAN. Now let me explain the model or explain much with. The following figure is the structure of the proposed model. The goal is to learn the distribution of minority class images through step 1 and 2 and finally drive the fake images for the minority class images distribution to augment that class. I will explain the process of the model. First, I learned the distribution for minority class. For this purpose, I use a one-stage anomaly detector called CUFACE, which augments the anomaly images by cutting a minority class image and a random portion of that image and pasting it into a random location in that image. When I run the CNN classifier, it runs the distribution of minority class images and detects image with other distribution as anomaly. This allows me to derive anomaly map and anomaly score if they do not correspond to minority class images. Next, using the trained one-stage anomaly detector as a discriminator for GAN, a data augmentation model. The generator initially derived random noise images. The more model learns the distribution of images, the more derived images such as real minority class images. Since the one-stage anomaly detector is replaced with a discriminator, the anomaly map and score are derived directly from the discriminator. At this time, the anomaly map and score can see the difference between the generated image and the actual distribution of minority class images. This is used to be feed feedback to generator. Use the generator learned in step 2 for data augmentation. A generator that has learned the image distribution of the minority class will receive random noise and derive a random image within that class image data distribution. Data augmentation is performed for a minority class by using the derived images as training data for the classifier. Let me explain the implications of this study. The first is that I replace the discriminator with the anomaly detector. The one-stage anomaly detector used in our study is phased anomaly detector. This augment the training outlier images by cutting and pasting random site from minority class image into random location. Through this, when a CNN binary classifier is trained through the constructed dataset, it learns the distribution of minority class images well and detect the run out of distribution images as outliers. Additionally, GradCam is applied to derive the anomaly score and map. The purpose model purpose to use the anomaly detector, which has learned the distribution of minority class images as a discriminator for GAN. This classifies the images generated by the generator to match the distribution of minority class images through anomaly detection. The second is it is possible to derive the anomaly map based attention map directly through the discriminator. Since the discriminator was replaced with the one-stage anomaly detector, it is possible to derive the anomaly score and anomaly map. It is possible to classify the real image and the fake image through the anomaly score. At this time, the real image is normally generated minority class image and fake image become a minority class image that has not been well generated. In the case of the anomaly map, the location of the advanced for classification as a fake image is displayed. In other words, this is a fault that the generator does not generate well, and this study purposes to use it for the generate learning as an attention map. Finally, the generator that runs will receive random noise and derive random images within the minority class images distribution. The derived images used as the training data of the classifier to augment the data of the minority class. Accordingly, unlike the previous one, attention-related information is derived through the discriminators. In addition, the derived attention map is capable of giving explanation to images currently being generated by the generator. Thank you.